This video will be our first video where we deal with solving probability problems. If you go to our website at digital-university.org and look in the combinatorics and probability section, you'll see we have 10 different videos already posted on how we solve different types of permutation problems. And then we have another 10 videos where we solved different types of combination problems. Afterwards, we had a series of videos dealing with binomial expansions and how to perform binomial expansions when you have a negative exponent. Then, with this background, we developed some of the more common types of generating functions, and then we had videos showing how to use generating functions to solve some of the more complicated permutation and combination problems. Now, for our probability videos, we're going to draw upon knowledge of these earlier videos right here. So, as we're solving a particular type of probability problem, if we're referring to some of the math techniques that we used in the earlier videos, and if you're not familiar with the technique, again, if you go to the website at digital-university.org, then you can go back and you can find those earlier videos. Okay, for our first problem, our first probability problem, it states this. We have a group of people with 8 men and 6 women, and we're going to randomly select 3 people from the group. If we do that, what is the probability that in that random selection of 3 people, it will be comprised of 1 man and 2 women? So again, we have 14 people total, 8 men and 6 women. We're going to select 3 of them at random. What are the chances, what is the probability that in that subgroup of 3 people, it will have 1 man and 2 women? That's the problem we want to solve. So here we have it just kind of crudely diagrammed out. There's our group of 14 people. It has 8 males, 6 females, and we want to select 3 of them. And we're saying if we select 3 of them at random, what are the chances that this group of 3 people will have 1 male and 2 females? Well, there's 2 things that we have to figure out. We have to determine then what is the total number of ways that we can select 1 male and 2 females from this group. The other thing we have to determine is, if we have this group of 14 people and we just select 3 people at random, what is the total number of ways that we can do that? Then what we do is, once we determine this, how many ways we can select 1 man and 2 women from the group, and divide that by the total number of all possible selections, that will give us then our probability of this particular selection. So let's figure out the second part first. Here we have 14 individuals. We're going to select 3 individuals at random. How many different ways can we do that? And if you remember from our combination videos, that answer is just simply this. Here we have 14 individuals. We're randomly choosing 3 of them. The order in which we choose them has no relevance whatsoever. So the number of ways that we can select 3 people from among the 14 is just a simple combination problem. And of course, that is this binomial coefficient, 14 over 3. So this is the total number of all possible selections when you're choosing 3 people. So this is the total number. Let's see, total number of ways to select 3 people. To select 3 people from a group of 14. Okay, now what we want to determine is what is the total number of ways that we can select 3 people so that it's comprised of 1 male and 2 females. Well, here's our group right here. We have 8 males and we have 6 females. How many ways can we select 8 males out of this group? And again, if you remember from the previous combination videos, that is just simply this expression. There are 8 males. We're going to choose one of them. The order in which we make the selection has no relevance, so that's just a simple combination problem. How many ways can we select 2 females? Well, there are 6 females in the group, so from the 6 females in the group, we're going to randomly select 2 of them. The order in which we make the selection has no relevance at all, so this would be the total number of ways then that we can select 2 females from the 6 females that comprise the group. Now, by the counting principle, if we multiply these 2 expressions together, this will give us then the total number of ways to select 1 man and 2 women from the group of 14 people. So this is a total number of ways to select 1 male and 2 females from the group of 14 people. From the group of 14 people. And again, in this group of 14 people, there are 8 males and 6 females. Okay, but multiplying these together, this tells us the total number of ways then that we can select 3 people, where amongst these 3 people we have 1 male and 2 females. This tells us the total number of ways to select 3 people from the group. So if I divide this by this, then that tells us the probability of selecting 1 male and 2 females. And this, of course, is just the binomial coefficient, 8,1 times, try to keep things in better focus. This is the binomial coefficient 8,1 times the binomial coefficient 6,2. Now, let's just take a look at this binomial coefficient expression. That's 8,1, so that would be 8 factorial over 1 factorial times 8 minus 1 is 7 times 7 factorial. So this binomial coefficient is this. Well, 8 factorial, that's just equal to 8 times 7 factorial. And down here we have 7 factorial. This cancels. So this binomial coefficient is just simply equal to 8. Now, let's make some room so we don't get things too confusing. So this binomial coefficient is just 8, so we're going to replace that with just the number 8. So 8 times this binomial coefficient, that's the total number of ways to select 2 females and 1 male from that group. This binomial coefficient is the total number of ways to select 3 people from the group. So we want to divide this by this. So let's make some room and do that. And actually, before we do the division, let's figure out what this binomial expression is. Here we have 8 times this binomial coefficient. So here we have 6 factorial divided by 2 factorial. And 6 minus 2 is 4 times 4 factorial. So this is equal to 6 times 5 times 4 factorial. Are we keeping things in focus well enough? Divided by 2 factorial times 4 factorial. And 2 factorial, that's just 2. So these cancel. 2 goes into 6 3 times. So this is 15. So this binomial coefficient is 15. So 8 times 15, that's 120. So that tells us there is 120 different ways to select 1 male and 2 females from this group. Okay, now what is the total number of ways that we can select 3 people from this group? That's this binomial coefficient right here. So now, let's make some space. Our probability of selecting 1 male and 2 females from the group is 120. That's the total number of ways that we can make this selection, divided by this binomial coefficient. Okay, this is the total number of ways to select 1 male and 2 females from the group. This binomial coefficient is the total number of ways to select 3 people from the group. So when we take this ratio, that will tell us then the probability of choosing 1 male and 2 females, selecting them randomly from this group of people here. So all we have to do now is figure out what this binomial coefficient is. So let's do this separately. Here we have, this is 14 factorial. Are we keeping things in focus? This binomial coefficient, 14 factorial divided by 3 factorial. 14 minus 3 is 11 times 11 factorial. That's this binomial coefficient. So let's see. This is 14 times 13 times 12 times 11 factorial divided by 11 factorial. And 3 factorial is 3 times 2 times 1, that's 6. Okay, so here the 11 factorials cancel. 6 goes into 12 2 times. So this binomial coefficient, which is this, is equal to 14 times 13 times 2. So this expression here is equal to 120 divided by 14 times 13 times 2. 14 times 13 times 2. Okay, let's make some room. We're almost at the end now. Let's see, this is 60. So this equals 60 over 14 times 13, or that would equal 30 over 7 times 13. And 7 times 13 is 70 plus 21. That's 30 divided by 91. So this finally then, this is the probability right here of when we are randomly selecting 3 people from this group of 14 people, and when we do the random selection of taking 3 people, of having 1 male and 2 females, the probability of that happening is 30 over 91, or very close to 1/3. So there's our answer. I hope it wasn't too long and too tedious. We're trying to point out, some of the logic that's involved here when solving these problems. But anyway, this is our first probability solving videos. And again, if these binomial coefficients are not familiar with you, or exactly what we mean when we're saying doing a combination problem, if you can go back to the earlier videos in this series, we have all that worked out in great detail. Okay, that's it for this problem. Hope it was worthwhile for you. Come back and join us for some more videos, and we'll try and solve some more problems.